Hey everybody, Mr. Morrell here, and we're going to talk about trying to decide if we are seeing a function or not. Again, this whole unit is about introducing this idea of a function, and we're kind of taking our time and talking about things that seem really silly because we really need you guys to have a deep understanding of what a function is, because, like I said, basically from here on out you will only be dealing with functions. It'll be very rare occasion when you deal with the letter y anymore. So let's start off with the definition of a function. A function is a relationship between inputs and outputs, such that for every input, there's exactly one output. Now let me just sketch a function machine that you probably saw in class, whether it was in my class or your own class. The idea here is that we've got a function machine, and we just don't want any surprises. So what that means is when we put some number in, let's say I put a number 2 into my machine, I need to know exactly what will come out. If I can tell you exactly what will come out, we've got a function. If there's a question, because maybe one or more things may come out if I put a 2 in, then it's not a function. And I'll show you what I mean here in a second. I think I picked bad examples to do, but I'm going to do it nonetheless. Okay, question number 2. We're trying to decide if it's a function or not, so all I need to do is to look. Okay, well, if I put a negative 2 into my machine, it gives me a 3. If I put a negative 1 in, it gives me a 2. If I put a 0 in, it gives me a 1. If I put a 1 in, it gives me a 1, or 0. 2 in, gives me a negative 1. 3 in, gives me a negative 2. There was never any question about that. Now, let's pretend, for example, that these numbers were negatives. If those numbers were negatives, well, if I put a negative 2 in to my machine, I would have gotten a 3 or a negative 1. I wouldn't be quite so sure. So that would be an example of a non-function. But in this example, where we only have one copy of each input, we can say, yeah, that is a function. There's no question there. I know exactly what I'm going to get when I put my numbers into my machine. So, question 4 is a little tricky because you started seeing these duplicate outputs like this. But don't worry, because, the idea is that whatever size of cap you buy is going to depend on the size of your head. So if your head is 25 inches tall, you know you need to get a small cap. If it's 26 inches tall, why am I saying tall? If your hat is 26 inches round, big, in circumference, I don't know, then you know what hat you should get. Every single input is unique here in this table. So yes, that is a function as well. Okay, now again, down here, let's look at question 6. I know it's kind of weird because everything is pointing at this 5. And even though lots of different inputs give you a 5, it's okay because we always know for every single input what is going to come out of it. If I put a 2 in, I get a 5 out. If I put a 0 in, I get a 5 out. If I put a 1 in, I get a 5 out. If I put a negative 4 in, I get a 5 out. There's a function as well. Now let's talk about graphs here. Graphs are a little tricky. Your x-axis is going to be your inputs. Your y-axis is going to be your outputs. So here's what I mean by that. This dot right here represents the point negative 4, 3. In other words, if I put in a negative 4, I get a 3 out. Right here, this dot represents 0, 3. If I put a 0 in, I get a 3 out. This dot represents 1, negative 2. If I put a 1 in, I get a negative 2 out. This dot right here represents 4, 2. If I put a 4 in, I get a 2 out. But you may have noticed this dot down here also represents 4, negative 4. In other words, in this machine that we have set up, if I put in the input of 4, it's possible that I'm going to get one of these two outputs come back at me. So for this reason, no, question 8 is not a function. Okay? So again, kind of a good quick way to see that is if you ever have two dots, one on top of the other, that means that they share the same input, but they have different outputs. And that kind of clogs up your machine. So like if we go back up to our picture with this example we just talked about, using that graph, I put a 4 into my function. Well, I don't know if I'm getting a 2 out or a -4. So because the machine doesn't know which one to give me, kind of like I explained it like the function machine breaks, and we no longer know what's going to come out of it. So here, let's look at question 10. Question 10, there's no other dot on top of or below of that dot. None there, oh, none here, and none here. Every input in this graph has only one specific output. So question 10 is an example of a function. Then we can look at the next page. Alright. So again, the idea is that we're looking for duplicate x values with different y values. So I'm going to look here at question 12. I've got a -1, a -3, a -1, a -5, and a 10. Well, we've got a problem because if I put a -1 into my machine, it doesn't know if it should give me a 0 or a 6. So our function machine breaks. This is not an example of a function because for one input, -1, I have two different outputs, 0 and 6. Alright? So that's kind of the idea you want to think to yourself. Now I'm going to help you answer question 13, but I'm going to need you to write the answer in your own words. A way to think about the relationship between the temperature outside and every second of the day. So like if you wanted to, you could kind of imagine this line representing temperatures as your input. So if your x value was a temperature, and the output was what time of the day was that temperature. Well, to me, like, okay, I'm looking at my thermometer. I have a thermometer outside, and I'm looking at it, and it's kind of cold right now. It's about 35 degrees. Well, it's been 35 degrees for the last several seconds. So if I were to type into a computer something like when was it 35 degrees outside with a question mark, maybe my computer would give me lots of different answers. There's tons of outputs for that single input. So in this example, no, that is not a function, because for any given temperature, it's possible that it was that temperature lots of different times of the day. Alright? So those are things for you to be thinking about, and make sure you kind of write that in your own words. And then you've got question 14 there as well. Then, you got to be creative on level 4. I am not giving you, it's like I've given you some of the information, and you need to finish it up. So for example, in question 14, you need to finish the representation so that they are functions. In other words, you need to finish the row so that you still have a function. You need to draw arrows so that you do have a function. And you need to put a new dot on the graph so that you have a function. Notice I have those instructions right here. You fill in the missing row, you add mapping arrows, you add a dot. And then for question 15, you need to add things to make it so that it's not a function. So for example, you need to fill in the missing row in a way that it makes the table not a function. You need to draw arrows in a way that the map is no longer a function. And you need to add a dot in a way that it makes the graph so that it's not a function. Okay, well that was this video for today. We will talk about function notation next time, and that will be our last video before we do our end of unit test. I hope you are feeling like this has been a magical moment for you, and that you are anxiously awaiting to come visit me for the next video. So I'll talk to you later. Bye!